Good morning viewers, this is M. Raj Kumar, Dean of Academics, Mother Teresa Institute of Pharmaceutical Education and Research, and today I would like to discuss about factors affecting absorption, which is very important topic in absorption. If you understand the absorption, you can understand each and everything in biopharmaceutics. Let us discuss about the factors affecting absorption. So in factors affecting absorption, majorly two types of factors will be there. One is pharmaceutical factors, and second one is the patient related factors. Pharmaceutical factors, patient related factors. Yes, we can also call as a patient related factors as a biological factors also. So there is two factors, that is, one is pharmaceutical factors, second one is a patient related factors. In pharmaceutical factors, it is divided into two parts. One is physicochemical properties of the drug substance, which is already studied in your physical pharmacy, and comes to pharmacotechnical factors. It's also called as a dosage form factors. So pharmaceutical factors are divided into two parts. One is the physicochemical properties of drugs, and second one is the pharmacotechnical or dosage form factors. And comes to, let us discuss about the physicochemical factors. So in physicochemical factors, you know, drug solubility and dissolution. So one of a factor, drug solubility and dissolution. Second factor is, very important thing is particle size and surface area. Then comes to third factor, polymorphism and amorphism, and comes to pseudo polymorphism. And fifth factor is salt form of the drug, pseudo polymorphism, salt form of the drug, lipophilicity of the drugs. Then comes to pKa of the drug and intestinal or gastrointestinal pH, pKa of the drug and gastrointestinal pH. Then comes to drug stability, and then comes to last one is stereochemical nature of the drug. So you know, for the development of a dosage form, all these things are very important. So drug solubility is very important. If the solubility is there, then only dissolution will be happen. So if you want to increase the dissolution, then what do we need? There is a factor which is called as a particle size. If you decrease in the particle size, there is an increase in the surface area. So the factor will be very important. And there are number of polymorphism. You know about the polymorphism and amorphism. And then comes to pseudomorphism, nothing but hydrates and solvents, formation of a crystals like hydrates and solvents. Yeah, let us discuss each and everything in detail. Then comes to salt formation of the, if the salt formation of the, for example, diclofenac is the drug. If you make it into salt formation, diclofenac sodium, which is having a more soluble than when compared with the diclofenac. So salt form of the drug may increase the solubility. Then comes to lipophilicity. Lipophilicity is the factor which can influence the permeability of the drug. If the drug having a lipophilicity, the drug will be easily permeable. Then we have to understand about the lipophilicity of the drug, which is very important physicochemical property. Then comes to pKa, which is very important, pKa, and then comes to gastrointestinal pH. Based upon the pH of the drug, pH of the gastrointestine, there is a solubility of the particular drug will be depends, ionization will be depends. So very important, we have to know about the gastrointestinal pH and pKa of the drugs. And then comes to drug stability. Whatever we do for the development of the drug should be stable. So that's what a very important thing, we have to know each and everything in detail about the drug stability. And then comes to stereochemical nature of the drug. So stereochemical nature of the drug is nothing but formation of isomers. If the isomers if the nature of the isomers, based upon the nature of the isomers, we can decide the effectiveness of the drug. So these are different physicochemical properties. So again, I am telling that these are different physicochemical parameters or properties or factors which will be very useful to understand the concept of drug development in the absorption. Then comes to drug solubility and dissolution. You know, in the last video we discussed about what is meant by solubility and what is meant by dissolution, and what is the difference between these two. I already told you that solubility is the static parameter and static property, and dissolution is the dynamic process. So solubility is the static property and dissolution is the dynamic process. That's what we have to understand. So now we are going to discuss about the dissolution. Dissolution, you know, dissolution is simply converting of a mass transfer of a drug into the dissolution medium. Yes, how the mass is getting transferred, that's what is very important. So let us think, if you take a tablet, have to convert into the solution, nothing but the drug which is present in the tablet have to come out and mix in the dissolution medium, whatever it may be, maybe the HCl, maybe the phosphate buffer, whatever it may be, whatever the drug which is present in the tablet have to come out and mix with the dissolution medium. That is what the process which is very very important. For this process we have to know the different theories, that is called as theories of dissolution. Theories of dissolution is three types. One is a diffusion layer theory, or we can call it as a film theory. Then second one is a Danckwerts model or surface renewal theory. Danckwerts model or surface renewal theory. Then comes to last one is interfacial barrier model. We can call it as a double barrier model, and we can call it as limited solvation theory. So there are three types of dissolution theories. How the drug is coming out of the tablet and mixing into the dissolution medium is very very important. For that understanding of the concept of these things, there are three assumptions by the scientists that are theories of drug dissolution. One is a diffusion layer or film theory, Danckwerts model or surface renewal theory, and third one is interfacial barrier model, or we can call this as a double barrier model and limited solvation theory. So people may confuse between these three. So there is no confusion, simply understand the concept behind this one. So I am going to discuss about all these theories. Before going to that, I will tell what is the difference between these three theories, which is very very important. If you know the difference, you can easily remember. That's what important thing. Different diffusion layer or film theory. So here stagnant layer. So remember that in diffusion layer theory there is a formation of stagnant layer. Then in Danckwerts model or surface renewal theory, there is a packets will come and take a drug from the surface of the particular dosage form. Packets will come and take the drug from surface of the dosage form. Then in interfacial or barrier model, there is a formation of intermediate simply there is a formation of intermediate stage. From that the drug will be released. So this is what the difference between in diffusion layer, formation of a stagnant layer. From the stagnant layer the drug will be released. In Danckwerts model, there are the number of packet type of things will come to the surface of the particular dosage form and take the drug from it and leave it in the dissolution medium. And then in interfacial barrier model, there is a intermediate formation will become forms and the drug will be released from the intermediate stage. So hope you understand. Diffusion layer థియరీలో స్టాగ్నెంట్ లేయర్ అనేది ఒకటి ఫామ్ అవుతుంది, అండ్ డాంక్వర్ట్స్ మోడల్లో ప్యాకెట్స్ అనేవి వచ్చి సర్ఫేస్ మీద ఉన్న డ్రగ్ని తీసుకొని వెళ్ళి డిజల్యూషన్ మీడియాలో కలిపేసి మళ్ళీ ఫ్రెష్ ప్యాకెట్స్ అనేవి రిటర్న్ వస్తాయి. సో హోప్ యూ అండర్స్టాండ్. ఫస్ట్ దాంట్లో నథింగ్ బట్ డిఫ్యూజన్ లేయర్ మోడల్లో ఒక స్టాగ్నెంట్ లేయర్ అంటే ఫర్ ఎగ్జాంపుల్ ఒక ట్యాబ్లెట్ ఉంది, దాని చుట్టూ ఒక లేయర్ ఫామ్ అవుతుంది, దాన్ని స్టాగ్నెంట్ లేయర్ అంటారు. ఆ లేయర్లో డ్రగ్ ఇలా ఉంటుంది, ఈ డ్రగ్ ఇక్కడ నుంచి డిఫ్యూజ్ అయ్యి డిజల్యూషన్ మీడియాలోకి కలుస్తుంది. దట్స్ వాట్ అబౌట్ diffusion layer theory. You can call it as a simple, if this is called a stagnant layer is called as a film, then we can call it as a film theory. In Danckwerts model, some packets will come and take the drug from the particular dosage form, then it will go away into the dissolution medium and release. అక్కడ తీసేసుకొని సర్ఫేస్లో తీసేసుకొని వెళ్ళి డిజల్యూషన్ మీడియాలో కలుస్తాయి. అండ్ ఇంటర్ఫేషియల్ బ్యారియర్ మోడల్లోకి వచ్చేవరకు మధ్యలో ఇంకొక స్టెప్ ఫామ్ అవుతుంది. ఆ స్టెప్ అంటే డ్రగ్ రిలీజ్ అయ్యి ఈ స్టెప్లో మొత్తం అక్యుములేట్ అయితే ఇక్కడ నుంచి డ్రగ్ అనేది రిలీజ్ అవుతుంది. సో దట్ ఈస్ వాట్ ద డిఫరెన్స్ బిట్వీన్ దీస్ త్రీ. అండ్ we have to discuss about each and everything in detail with a mathematical description.